The lesson outcome for this video is I can graph quadratics by using the quadratic formula and the vertex. So again, this is kind of a lesson that combines several things that we have already done in this course. First, using the quadratic formula to find our x-intercepts. We've been working on that this past unit or two. And then second, graphing the parabola using those two x-intercepts when the y value is 0, and then using just one other point, which is the vertex. And if you remember, we found the vertex in the previous lessons when we factored to find our x-intercepts by adding the two x-intercepts and dividing by 2 to find that middle line or the line of symmetry that helps us find the vertex. So let's run through this first example and hopefully it'll come back to you. All right, so first of all, we'll start with naming our A, B, and C value so that we can use the quadratic formula. A is 2, B is negative 2, and C is negative 15. All right, so let's fit them into our quadratic formula. X equals negative B, and B is negative 2, so remember that's negative negative 2, which you can turn right into a positive 2 if you'd like, plus or minus the square root of B squared minus 4 times A times C. Again, that's a minus right there. All divided by 2 times the A value. All right, so we're going to simplify this. X equals negative negative 2 is positive 2 plus or minus the square root of, again, negative 2 squared is negative 2 times negative 2, which is positive 4, not negative 4. And then we have here minus 4 times 2 times negative 15. Notice we'll multiply negative times a negative, which will become a positive. So we're going to have plus 4 times 2 is 8 times 15 is 120. All divided by 2 times 2, which is 4. All right, we'll work up here. So x equals 2 plus or minus the square root of 124 divided by 4. So we get x equals 2 plus or minus the square root of 124 when rounded is 11 and 136 thousandths, so 0.136 divided by 4. So we'll split those two up, the plus and the minus. We have x equals 2 plus 11.136 divided by 4, or we have x equals 2 minus 11.136 divided by 4. So we'll compute those. And be careful to divide by 4. A lot of times we end up dividing by 2, but we are dividing by 4. So we're going to get 3.284 as one of our x-intercepts. And x equals negative 2.284 for our other x-intercept. And we can put those in our table down here. So when y is 0, x is 3.284. Or when x is 0, when y is 0, x is negative 2.284. Okay, so the second step in graphing this parabola is to now find the vertex. And again, remember that. Let's go ahead and plot these x-intercepts on our graph over here. So 3.2840. All right, from the origin going on the x-axis, 3.284 would be right around in here. Okay, it's about 3 1/4, right? Not 3 1/2, not 3, but 3 1/4 right here. So I'm going to put a point there. And then our other x-intercept is at negative 2.284. Again, negative 2 and a little bit more, so negative 2 and almost 1/4, which will be right around in here. And there's our two x-intercepts. Now remember, when we have a parabola, And this is going to open up because that front a value is positive. So we're going to have some sort of parabola that's curving in this sort of fashion. Well, we need to find where that vertex is. And I know the vertex is going to be directly in between the two x-intercepts on this vertical line, the line of symmetry. Again, we find that by adding our two x-intercepts and dividing by 2, which will give us the middle value. So that's what we're going to do next. We're going to add 3.284 plus our negative 2.284, and that will give us 1 when we subtract that. And then we need to divide that by 2. So now we have to do 1 divided by 2, and 1 divided by 2 is the same as 1/2, or 0.5. So we now know that our line of symmetry is at the line 0.5, so 1/2, which is kind of where I was showing it earlier, right in here. That's our line of symmetry, and we can draw that in here. Remember, we draw that in kind of like a dotted line. It's an arbitrary line that we use right there. So 0.5 is an x value of our vertex, is the x value of our vertex. And remember how we find this y value is simply putting that 0.5 into the original equation for both of the x's and finding the output for y. So go ahead and calculate that. When we calculate, you'll find this is, again, slightly off of our graph like a previous lesson was. I'm not being super careful. I apologize for that. So y is negative 15.5. So when x is 0.5, y is negative 15.5. So notice that it's going to be, again, down here, lower than our graph goes, and we can actually probably estimate it right in this region here. Probably right about, whoop, that's pretty bad. Let's try again. Probably right in that region there. So negative 15.5. And now we can graph our parabola using those 3 points. And there we go. So the second example is pretty similar to the first, and we are going to go ahead and use the quadratic formula. Then we'll find our x-intercepts, find the vertex using those x-intercepts, and graph. So if you'd like to try this one on your own and then check to see how you did, you can do that. If you want to just try step 1 and then check to make sure that's fine, and then do step 2 and then 3 and then graph it, that would be fine too. However you'd like to go ahead and do this problem. Okay, so our a value is 2, our b value is negative 1, okay, right, because there's a negative 1 right there, and our c value is negative 2. Go ahead and put those into our quadratic formula. All right, and we will simplify. X equals negative 1 is positive 1. Plus or minus the square root of negative 1 squared. Again, be careful. Negative 1 times negative 1 is positive 1. When we do our math here, we're going to have a negative times a positive times a negative, so that will become positive. 4 times 2 is 8, times 2 is 16, and divided by 2 times 2, which is 4. X equals 1 plus or minus, again we're coming up here, the square root of 17 divided by 4. We know the square root of 17 is going to be just over 4 because 4 times 4 is 16, so 4.123 divided by 4. And then we'll go ahead and break this down into our plus and our minus. So 1 plus 4.123 divided by 4, and x equals 1 minus 4.123 divided by 4. We'll compute those two x values. Again, be careful that you add or subtract the numerator and hit enter before you divide by 4 or use parentheses. So we will get 1.281 or negative 0.781. Those are our two x values, our x-intercepts, 1.281 and negative 0.781. If we plot those x-intercepts on our graph, we will find that one of them is at about 1 1/4, just over 1 1/4. So that's right in here. And the other one is negative, so it's on the left-hand side of the y-axis. And it's, well, about, again, negative 3/4, just a little bit more than negative 3/4, because 3/4 is 0.75. So this is negative 0.78. So it's not all the way to negative 1, but it's greater than negative 1/2. So right in this area here. All right, to find the vertex, go ahead and, if you'd like to pause the video and find that, and then check back to see that you did that appropriately. Okay, so you have to take the two x-intercepts and add them. And we get positive 0.5. And remember, we need to then take that 0.5 and we have to divide it by 2. So that's like taking a half and dividing that by 2, so it's 1/4. So 0.25 is our line of symmetry location, so 0.25 or 0.25. That's at 1/4, so it's right close, whoops, not there, let's see. It's close to the y-axis. And does that location make sense based on our two x-intercepts? Sure, seems like it's right in between the two. And now we plug that value in for x to find our y value for our vertex. When you plug that value into the equation, both here and here for x, we will find that our y value is negative 2.125. So we can plot that on our red line there, our line of symmetry. So 0.25 comma negative 2.125. That's going to be right in this region right there. And now we can draw our parabola. And I did miss that first x-intercept there. There we go. One of those lines is on there, right? Or curves, I should say. And there we go.